Triangle Midsegment Theorem, applicable to band directors. What is the Triangle Midsegment Theorem? If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half its length. Let's apply this theorem to the life of a band director. Imagine you're the band director for the Vista High Regimental Band and Pageantry. In your field show, the band kids have formed a triangle. You want the pageantry kids to form a triangle connecting the midpoints of each side of the larger triangle. There's one band or pageantry kid per yard. The base of the large triangle is 50 yards, and the two legs are 32 yards. How many yards is each side of the inner triangle, and how many pageantry kids will you need to create each side of the inner triangle? Here's a drill chart showing the triangle that the band kids have formed. If you made the triangle midsegment theorem into an equation, it would look like the equation in the top left corner. Let's first look at the base of the triangle. If we inserted 50 for x, then m would equal 25. Therefore, the midsegment parallel to the base is 25 yards. Now let's look at one of the legs. If we insert 32 for x, then m will equal 16. So the midsegment parallel to that leg is 16 yards. Since the two legs are congruent, then the remaining midsegment will also be 16 yards. Conclusion. We figured out how many yards each side of the inner triangle is. Now we must find out how many pageantry kids we need to make the formation. Remember that there is one band or pageantry kid per yard, so all we have to do is add up the sides of the inner triangle to get the number of pageantry kids needed for the formation. So 16 plus 16 plus 25 equals 57. Thus, you will need 57 pageantry kids to form the inner triangle. How many yards is each side of the inner triangle, and how many pageantry kids will you need to create each side of the inner triangle? Two sides of the inner triangle are 16 yards, and the other side is 25 yards. You will need 57 pageantry kids to form the inner triangle.